Good morning students, welcome to session 6 on numerical analysis. In this session we are going to study about the solution of nonlinear equations. So first let us see about this is a linear and nonlinear equations. The equation in which unknown variable appears in degree 1 is known as linear equation, and if the equation in which unknown variable occurs in degree more than 1 are called nonlinear equations. So for example here, linear equations means an equation which appears first degree equations. So here it is, let us take example, it is x square plus 2x plus 1 equals to 0. This is second degree equation, means highest power of the variable here is 2, and it is x cube minus 1 equals to 0, it is third degree equation, and we have x plus sin x equal to 0 and e raised to x minus 2x is equals to 5, etc. These are all what here? These are all nonlinear equations. So we can call these equation which contains sin x and e raised to x. We can also call it as a transcendental equations which contains trigonometric and exponential functions, and other than these we can have logarithmic functions also. And these are algebraic equations. And to solve these equations we use many methods here. So there are two types of methods to solve these equations. One is analytic method, another is the numerical method. So in analytic method it is very difficult to find the solution of these types of equations. So for that purpose we use numerical method here. So in numerical method we use some iteration method, means first we have to, this is numerical method is an approximate method. So here we use some approximate method. This is an approximate solution. So we use one method here and we use the same solution repeatedly to get the accurate value. So we can call it as iteration method. So for this here, to solve this nonlinear equations we have different methods. So that is these are the methods to solve nonlinear equations. First one is bisection method, and second one is method of false position, and third one is Newton-Raphson method, and last one is secant method. So these are all different methods to solve the nonlinear equations in the numerical way. Let us start with the first method, that is bisection method. So bisection method means here in this case one equation is given, f of x equals to 0 is one equation here. If this equation is given, be the given equation, and let a and b be the real numbers. This may be given or may not be given, such that here f of a into f of b is less than 0. So means here, so what is given? F of x equals to 0 is an equation. I will tell you one example here. Suppose here f of x is equals to, this is nonlinear, means the equation must be greater than, whose degree is greater than 1. Let us take here x square minus 1. So here suppose it is here it is given that here a and b are two real numbers, no, such that f of a into f of b is less than 0. Means here let us take here a is equals to 1. So it is a is equals to x square minus, let us take here a is equals to 1 and b is equals to 2. So what we have to do is here f of a means f of 1. F of 1 is what here? 1 square minus 2. It is equals to 1 square is 1 minus 2 is minus 1. And f of b is f of 2. F of 2 means here 2 square minus 2. 2 square is 4, 4 minus 2 is 2. So these two are what here? These two are in opposite signs. That is f of a is minus and f of b is plus. So f of a is minus and f of b is plus. So in this case here, so such that here f of a into f of b is less than 0, means their product here. So f of a is minus 1 and f of b is plus 2, no? And their product f of a into f of b is minus 1 into 2 is equals to here what? It is equals to minus 2. So here we can see here f of a into f of b is equals to minus 1 into 2 is equals to minus 2. It is what? It is negative. It is less than 0 we can take here. So that is f of a and f of b are of opposite signs. Then we say that there exists a real number, there exists a real root of given equation in between a and b. So that is in this interval the root lies between what here? The root lies, this is compulsory. If their product is less than 0, then only one of the root lies between in this interval here. That therefore the root lies between the interval a and b. That is here it is in between 1 and 2, that is in the example. So in general it is a and b it is. Then step 1. Bisect the interval a comma b to get the first approximation to the desired root. That is, here in this case f of a and f of b are of opposite sign. In that case the root lies between a and b. Then for the first approximation is x1 is equals to a plus b. Divide this interval by 2. A plus b divided by 2. Then to evaluate f of x1. So that is, here f of x1 means we will get some value here, that you have to find f of x1 means in that equation f of x you have to put x equals to x1, you will get one value. So again f of a into f of x1 you have to find here. So if the product is less than 0, then we conclude that the root lies between a and x1. Means we have seen here f of a has some value and f of x1 has some value. If the product is negative again, then the root lies between a and x1. And so in this interval or else if it is not less than 0, then we have to verify it for b value also. Then it is f of x1 into f of b. If it is less than 0, then the root exists in the interval x1 comma b. So in any one case here, so in these two any one is correct here. Then the next step is here what? Then you have to bisect the new interval either a comma x1 or x1 comma b to get the second approximation. Then step 2 is bisect the new interval either a comma x1 or x1 comma b to get the second approximation x2 to the desired root. Then again evaluate f of x2. So you have to find again f of x2 here. So then repeat the same process till the value of x is obtained to the desired degree of accuracy. So means you have to divide this interval once again. So that is, here x2 is equals to what again? So here you will get here x2 is equals to either it is a plus x1 divided by 2 or it is nothing but here x1 plus b divided by 2. Any one is correct because here it depends on the value of f of a into f of x1, whether it is less than 0 or f of x1 into f of b is less than 0. If which is less than 0, then if you divide that interval and take that one as x2, again you have to check f of x2 here. So if f of x2 is again find the value of f of x2, and next again you have to go for the interval, previous intervals you have to check here. That is, here f of x2 and f of x1 or f of x2 into f of it depends on the interval here, whether it is a comma x1 or b comma x2. It depends on the value here. So you have to repeat this process till to get the desired accuracy of the result. So this you will better understand while solving, after solving one example. So let us take one example here. Find the positive real root of x cube minus 3x square plus 1 equals to 0 by bisection method. Correct to 3 places of decimals. So here it is given that x cube minus 3x square plus 1 equals to 0, and take this one as f of x. Let f of x is equals to x cube minus 3x square plus 1 here. It is not equals to 0 here. You take only this is equation. So now first we find a and b, that is the interval a comma b in which the desired positive real root lies. So by inspection method, here they have not given any value of a and b here. So first this is by inspection method. So by inspection method you have to verify it for 0 and 1 here. So f of 0 means put x equals to 0 in this. So you will get here f of 0. That is, here f of 0 means 0 minus 0 plus 1 is equals to 1. And f of 1. So f of 1 means here put x equals to 1 here. You will get f of 1 is 1 minus 3 plus 1. So 1 plus 1 is 2. 2 minus 3 is how much here? Minus 1. So f of 0 is 1 and f of 1 is minus 1. So these are the values we have taken directly, because they have not given any a and b here. We have taken initial values here 0 and 1, and we have tested it for f of 0 and f of 1, and so they are opposite sign here. F of 0 is positive and f of 1 is negative. Don't see the value here, whether they are positive and negative, that only have to say here. So since f of 0 into f of 1, that is f of 0 is 1 and f of 1 is minus 1. So 1 into minus 1 is how much here? Minus 1, which is less than 0. Means that is negative. So f of 0 and f of 1 are of opposite signs. Therefore the root lies between 0 and 1. Now take a equals to 0 and b is equals to 1. These two values you have to take here, a equals to 0 and b equals to 1. Then we have here x1. This is the first approximation. So the root lies between 0 and 1. Therefore take this is equals to 0, 1. So divide this interval here, that is 0 plus 1 divided by 2, it is equals to 0.5. So now we have to take here, now we have to find f of x1. This value you have to take here. F of x1 is equals to f of 0.5 is equals to. So f of x here is equation is what? X cube minus 3x square plus 1. No? In that case you have to put x equals to 0.5. So 0.5 whole cube minus 3 into 0.5 whole square plus 1. And simplify this value. After simplification you will get here 0.375 which is greater than 0. It is positive. This simplification you do using calculator. So this is because calculator is also allowed in examination. So this is positive. Now again since here you have to check here. So before this, what are the values we have calculated? We have calculated f of 0 and f of. So before this what we have done here? We have done f of 0 and f of 1. We know f of 0 is how much here? F of 0 is 1, f of 1 is minus 1. So now f of x1. So f of x1 is how much here? F of x1 is 0.375. It is also greater than 0. So here it is greater than 0. Before this you have to check which value is less than 0. Here f of 1 is less than 0. You have to take these two intervals here. So next here, since f of 0.5 and f of 1 are of opposite signs, because here f of 0.5 is positive and f of 1 is negative. Therefore, they are of opposite signs. Therefore, the root lies between 0.5 and this one. The root lies between 0.5 and 1. So, you have to divide this interval once again here. That is x2, second approximation. x2 is equals to 0.5 plus 1 divided by 2. So, it is equals to 0.75. 1.5 divided by 2 is 0.75. Now, you have to find f of x2. So, f of x2 is again f of 0.75. It is equals to 0.75 whole cube minus 3 into 0.75 whole square plus 1. That is in the equation f of x you have to put 0.75. So after simplification you will get here minus 0.2656 which is less than 0. So here it is again a negative. Before this you have to check which value is positive. So before this what we have here? Before this here also we have here this is negative, no? F of x2 is negative and f of x1. F of x1 is what here? Positive. So they are opposite signs. F of x2 is negative and f of x1 is positive. Therefore the root lies between these two. So this implies here since f of 0.5 and f of 0.75 are of opposite signs. Therefore the root lies between 0.5 and 0.75. So this implies here again you divide this interval here. 0.75 plus 0.5 divided by 2. It is equals to 0.62. This is f of x3. Now you have to find f of x3. F of x3 is equals to f of 0.62 and it is equals to, again you have to substitute here 0.62. It is equals to 0.62 whole cube minus 3 into 0.62 whole square plus 1. Find this value. It is positive 0.085. It is again greater than 0. So f of x3 is greater than 0 and before this you have to check which value is negative here. F of x2 is negative, no? So therefore the root lies between here x2 and x3. So these two are of opposite signs. So therefore the root lies between here 0.62 and 0.75. So therefore again you divide this interval here. 0.62 plus 0.75 divided by 2, it is equals to 0.68. Now again you have to repeat the same procedure to get the desired accuracy of values here. F of x4 is again f of 0.68 and after simplification you will get here negative value. So again it is less than 0. So f of x4 is less than 0 and here f of x3, you see here f of x3 is positive. Therefore the root lies between x4 and x3, that is 0.62 and 0.68. Similarly next you have to divide this interval here. 0.62 plus 0.6 divided by 2, it is equals to 0.65 we got. Similarly, you have to find f of x5, that is f of 0.65 and substitute in the equation. After simplification, you will get here a positive value. So, f of x5 is positive and f of x4 is negative. Therefore, the root lies between x4 and x5, that is the root lies between 0.65 and 0.68. you have to divide this interval once again here. So that is 0.65 plus 0.6 divided by 2, you will get here 0.665. So same procedure you have to repeat here. F of x6 is again here, after simplification you will get here minus value. So f of x6 is negative, and f of x5 you have to see here. F of x5 is again what here? We have seen here f of x5 is positive. F of x6 is negative. So therefore the root lies between 0.65, f of x5 and x6, 0.665. So again if you divide this interval, you will get here x7, next approximation, it is equals to 0.657. Now find same f of x7, and this value after simplification will get negative. So f of x7 is negative, and f of x6 you see here, f of x6 is also negative, and don't take these two values here because both are negative. And before this you have to check f of x5. So we have seen here f of x5 is positive. Therefore the root lies between what here? Therefore the root lies between x5 and x7. That is, the root lies between 0.65 and what? The root lies between f of 0.65 and 0.657, because f of 65 is positive and f of 0.657 is negative. So don't see only the previous value. You have to go which value is which two values are of opposite signs. So therefore here 0.65, and this step is important here. You will observe this one value here. This is what here? This is positive and this one is negative. So therefore the root lies between these two values. So it is equals to, again divide this interval, x8 is equals to 0.65 plus 0.657 divided by 2. It is, you will get here 0.653. So this is x8. Now find f of x8. F of x8 is again a negative. So f of x8 is negative, and f of x7 is also negative. We cannot take these two values, and f of x6 is also negative. We cannot take this value also. But f of x5, we have seen here, f of x5 is positive. Therefore the root lies between here, what here? Root lies between x8 and x5. So that is f of 0.65 and f of 0.653 are of opposite sign. Therefore the root lies between these two values. So divide this interval once again here. So take this one as here, next approximation, x9 is equals to 0.65 plus 0.653 divided by 2, it is equals to 0.6515. So now f of x9 find, and this value is again positive here. So next, before this you check which value is negative. F of x9 is positive and f of x8 is negative. So they are of opposite sign. Therefore the root lies between x8 and x9. So that is, x8 is here how much? X8 is 0.653 and x9 is 0.6515. So they are of opposite sign. Therefore the root lies between this interval. So therefore we can divide this interval to get the next approximation. Take this one as x10 is equals to 0.6515 plus 0.653 divided by 2. It is equals to 0.6522. Here you will observe here x10 is 0.6522 and x9 is 0.6515. The values are similar up to 2 decimal places here, 0.65, 0.65, and we get the better approximation as up to 3 decimal places. So for that we are trying to continue this process. Now f of x10 is equals to f of 6522, and after simplification you got here positive value. So since f of x10 is positive, and before this here this value f of 0.653 is negative. So therefore these two values are of opposite sign. Therefore the root lies between these two values. So therefore take this one as here x11 is equals to, divide these two intervals, 0.6522 plus 0.653 divided by 2, it is equals to 0.6526. So x10 is 0.6522 and x11 is 0.6526. So here also we can take these two values are nearly same here, 0.652. We can take the value as 0.652 also. So now f of x11 you find here it is positive, and f of x11 is positive, and f of x10 is also positive, but f of x9 is here what? We have seen here f of x9 is also positive, and f of x9 is also positive, and f of x8 f of x8 is negative. So therefore the root lies between x8 and x11. So x8 is 0.653 and 0.653 and this x11 is 0.6526. Divide this interval, so you will get here 0.6528. See here x12 and x11. x11 is 0.6526 and x12 is 0.6528. They are approximately equal only up to 3 decimal places. So 0.652 and here also we have 0.652. So we can take here, since x11 and x12 are of same up to 3 places of decimal, hence the desired root is what? X is equals to 0.6528 we can take here, and it is approximately equals to, we can take 0.653. I told you how to make the round off, how to round off the number. Suppose we want to take only up to 3 decimal places, then you have to see the next decimal place. If the next decimal place is greater than 5, you add 1 in the previous digit and neglect this one here. It is 8, no? We can take 1 digit in this, so it becomes 3. So 0.653. Therefore, we can take here the root of this equation as x is equals to 0.653. This is the root of the, therefore the root of the equation here. What is the given equation? X cube minus 3x square plus 1 is equals to 0 is here what? X is equals to 0.653, because this is the one root here. It is x cube. Now we have 2 more roots that we can find here, but that is not asked here. It is only thing is you have to find the real root which lies between which satisfies this equation. So that is here x equals to 0.653 is the root of this equation. So this completes the solution. You just first you go through this example. If you find any difficulties, feel free to ask me any doubt. So thank you for watching this. Thank you.